Now we're going to go from writing formulas from a sequence. So here I have a sequence, 4, 7, 10, 13, and 16. This is a type that's fairly easy to do if we note that each step is 3. And we should remember that when we graph and we graph a line, it goes up the same amount each time that we go 1 unit. So this is going to be like similar to the graph of a line. So I'm going to say that a sub n is equal to, well, let's see. We're going up by 3's. So that would be like the slope of a line, 3n. And now we have to figure what would give me my starting number of 4. Well, 3 times 1 is 3, plus 1 will give me 4. So this tells me it's linear. Means I can use the slope and then figure out the first term. So anytime you're going up the same amount, that's going to be linear, slope, first term. And this is my formula, and you can see 3 times 1 is 3, plus 1 is 4, 3 times 2 is 6, plus 1 is 7, 3 times 3 is 9, plus 1 is 10, 3 times 4 is 12, plus 1 is 13. I get the sequence that I was looking for. This is the general formula, but what about a recursive formula? A recursive formula, we would know our first term is 4, and then we get each term if I take the term in front and add 3. So we're adding 3 each time, so that means I'm going to add 3 to the previous formula. Let's see if this works. A sub 1 equals 4, a sub 2 equals a sub 1 plus 3, which is 4 plus 3, which is 7. A sub 3 is going to be a sub 2 plus 3. That's going to be 7 plus 3, which is 10. And I'm generating the same formula. Other types of formulas are a lot more difficult. A very common one is this one. 4, 7, 12, 19, 28. When I look at this, and I look at how much I'm going up, that's going up 3, that's going up 5, that's going up 7, that's going up 9. When I see things going up by the odd number sequence, that is going to be like a perfect square. So that means I'm going to look at something that has n squared. So this would be a sub n equals, let's try n squared, and then see what will I need to make my first term. Well, 1, if I put an a sub 1, would be 1 squared plus something to give me 4. Well, that looks like 3. So I'm going to try a sub n equals n squared plus 3. Let's see if this works. A sub 1, we did. A sub 2 would be 2 squared plus 3. 2 squared is 4 plus 3 is 7. Very good. A sub 3 is, let's see, 3 squared plus 3. 3 squared is 9 plus 3 is 12. Well, that's working out good. A sub 4 equals 4 squared plus 3. 4 squared is 16 plus 3 is 19. We were able to generate the same formula by knowing that when we went up by odds, that usually means we had n squared. there are other types of formulas that are, very difficult to manage. Let's see if we can write a recursive formula for this one, and then we'll leave writing other formulas for later. Let's see if we can write a recursive formula. Well, we know a sub 1 is 4. Then a sub 2, now we're adding odd numbers. Odd numbers generally mean 2n plus 1. So I would have 2n plus 1, that's an odd number. And let's see, 2 times 2 is 4 plus 1 is 5, plus 2 to give me the next one. A sub 3 would be 2n plus 1. 2 times 3 is 6 plus 1 is 7. Oh, plus 5. Oh, that's going to be a bigger challenge. So we know a sub 1 is 4. A sub 2 equals a sub 1 plus an odd number, that's 3. That's 3 is 2n minus 1. Let's try that. So a sub 2 would be a sub 1, which is 4, plus 2 times 2 is 4 minus 1 is 3, plus 3 is 7. A sub 3 would be a sub 2, 7, plus 2 times 3 is 6 minus 1. 13 minus 1, that's 12. A sub 3 would be a sub 4, will be a sub 3 plus 2n minus 1. So that could be 12 plus 2 to 7, and that's 19. Okay, we were able to finally figure it out, how to use a recursion formula by adding odd numbers. Odd numbers are 2n plus 1, or it can be 2n minus 1. Other formulas are very difficult. It usually requires imagination to try and figure out, what formula you can use. It involves a lot of creativity as a mathematician. But that gives you an introduction of some basic things and patterns that will take care of some of the more easy types of formulas you have to write.